this video, our topic will be ionic bonding. First of all, how does basically ionic bond formation occur? Ionic bond formation occur due to the transfer of electron, transfer of electron from metal to a non-metal, to a non-metal. Okay. So one thing is quite clear to us that ionic bond is basically formed due to the transfer of electron from metal to a non. But main question arises here, why atoms make bond? Why atom make bond? So atoms make bond. The answer is that atoms make bond in order to stabilize themselves, in order to stabilize themselves, okay, to stabilize themselves by moving from high energy state to lower energy state, higher energy state to lower energy state, okay, lower energy state. The question here arises that what we mean by higher energy state, what we mean by higher energy state, and lower energy state. So atom wants to move from high energy state to lower energy state. So first of all, what is high energy state? Higher energy state is the state in which the atom has partially filled outermost shell. It has partially filled outermost shell. Okay, shell, and it moves towards the low energy state. That means completely filled outermost shell. Completely filled outermost shell. And the completely filled outermost shell in basically periodic table is of noble gas, is of noble gas. Noble gases, they are basically present in either in group 8, or we also call it as group 0. Okay, so every atom wants to attain the noble gas electronic configuration, that is of completely filled outermost shell. Okay, so in some books it is written that completely filled outermost shell is of noble gas. So every atom basically wants to attain the noble gas electronic configuration. Okay, so now how atoms make bond? How atoms make bond? Very important question. So they make bond either by transfer of electron, that basically occurs in ionic bonding, or either they share electrons, either they share electrons, and that we know that actually occurs in covalent bonding. Okay, in covalent bonding. I hope it is clear up till now. So, we know that first of all, ionic bonding, how does basically ionic bonding formation occur? First of all, let's discuss about the formation of, you can say, ketynes, formation of ketynes. So how does formation of ketine basically occurs? The formation of, first of all, ketine is a positively charged ion, positively charged ion that is formed, that is actually formed, that is formed by losing electron, by losing electron. Okay, like for example, we have sodium. We have sodium, which is Na1123, and its electronic configuration is, for example, we have, uh, let's say, it's sodium. So first shell can accommodate maximum of 2 electrons, we know, and second shell can accommodate, as it has total 11 electrons, so second shell can accommodate 8 electrons. And the last shell can accommodate maximum of 1 electron. Okay, 1 electron. So what happens? It is going to lose, it is going to lose 1 electron, and now you can say first shell the same 2 electrons, and second shell is also using is not losing any electrons, so it is completely filled 8 electrons. Now for third shell, it is only having 1 electron in its outermost shell, and it has to complete 8 electron in its outermost shell. So what is easy for sodium? Either to lose this electron so that outermost shell can hold 8 electrons, or either it would gain 7 electrons. Okay, so it has two options: either gain 7 electrons, or either lose 1 electron. So this option is quite easier for sodium. So it has lost 1 electron, and now it is having a positive charge on it, like this, okay, with the loss of electron. So this is basically the formation of a cation. Now let's move further and let's discuss about the formation of anion. Okay, so now we are going to discuss about the formation of anion. Okay, formation of anion is always occur with non-metals. Okay, because non-metals are electron deficient. Okay, so they are basically, they are have the tendency to gain electron. Like for example, we have chlorine. Okay, electronic configuration of chlorine is 287. As it has 1737. Okay, its atomic mass, so it has 17 electrons, so 287. Okay, so first shell can accommodate maximum of 2 electrons. Second shell can accommodate maximum of 8 electrons. And the third shell can accommodate maximum of 7 electrons. Okay, so now what happens? What is easier for chlorine? Either to gain 1 electron, either gain one electron, or either lose 7 electron to complete its outer motion. So this one is quite easier for chlorine. So it adopts this thing. So it is going to gain 1 electron, and now it is going to become an anion. Okay. So first shell of 2 electrons, second is of 8 electrons, and third one will also occupy now 8 electrons after gaining 1 electron. So what would be the charge on chlorine? Chlorine, as it has gained electrons, so the charge, as it has gained only 1 electron, so charge on it would become negative, okay? So now let's discuss the example of the formation of an ionic compound, that is formation of NaCl. NaCl. First of all, Na has this one like 11 electrons and 23 is its atomic mass. Chlorine is having the atomic mass of we can say 17, and if it's isotope then it would be 35.5 or 37 you can take. So now its electronic configuration is 281. It has to lose 1 electron to complete its outer motion, and it has to 8 7. It has to gain only 1 electron. So now what happens in sodium? First shell is of this 2 electrons, second is of 8 electrons, and third is also having only 1 electron. Okay. If you are drawing, as we know that sodium is basically a metal, okay? So what happens if you are drawing sodium with the electron of sodium with cross, then you have to draw the electrons of chlorine with dot. First shell of 2 electrons, and second shell is of uh, 8 electrons. Okay. Now what happens? 1 electron from sodium is basically transferred to chlorine. Oh, sorry. I have drawn its 8 electrons, but it has 7. Okay. So it has 7. So now what happens? 1 electron from sodium is basically transferred to chlorine. Okay. So first shell is of 2 electrons. Second is of 8 electrons. Okay. As it has lost 1 electron, so it is having a charge of positive with chlorine. Okay, with chlorine, we can say first shell is of 2, second is of 8, and now third one is also having how many electrons? 1, 2, 3, 4, 5, 6. It was having 7. And this cross electron shows that electron is basically transferred from sodium to chlorine. And now it is having a negative charge. Okay. Remember one thing, boys. There is strong electrostatic force of attraction. Strong electrostatic force of attraction between a cation and an anion. Force of attraction between a cation and an anion. And that is why, remember boys, a very important point. I want to highlight this point, that Because of the strong electrostatic force of attraction, ionic compounds would be having high melting point and boiling point. Would be having high melting point and boiling and boiling point. Now, let's move towards the next thing, and that is the formation of magnesium chloride. Magnesium is 1224. Its electronic configuration is 282. And we know chlorine is 17. Here is 37. Okay. So it would be 287. Now, what happens? In order to complete the outermost shell of magnesium, it has to lose two electrons. It has to lose two electrons. So it would combine with two. So during the formation of magnesium chloride, which is basically, we know that it is also an ionic compound. So magnesium, the electronic configuration of magnesium is 282. So it has to lose two electrons to attain the noble gas electronic configuration. Okay. So now what happens here? Let me just select this one. So now what happens here, that magnesium has two electrons in its first shell. Okay. So it has two electrons in its first shell and it has eight electrons in its second shell. Okay. So it has two electrons in its third shell. I'm using cross for magnesium, so I have to use dot for chlorine. So it has two electrons in its first shell. It has eight electrons in its second shell. Okay. So it has seven electrons in its third shell. Okay. And we know that as magnesium has to lose two electrons, but only one electron can be gained by chlorine. So in fact, magnesium is going to combine with two chlorine, with two chlorine. First shell would be two electrons, second shell would be eight electrons, and the third shell would be having also seven electrons. So what happens here? One electron from magnesium would be transferred to each chlorine. So one electron goes here and the other electron goes here. So now what happens? Only going to draw the outermost shell of magnesium. That would become 8 electrons, as it has lost these two electrons and that are going to be transferred to chlorine. So magnesium has like this kind of structure with a positive charge on it. Okay, so it has a positive charge of +2. Okay, so now chlorine would be having, I'm also going to draw its outermost shell. It has 7 electrons here, and we know that one is being transferred from magnesium, so it would be like this, having a negative charge on it, like this. And there would be another chlorine as well, that I'm going to draw the structure like this. The outermost shell would be having 7 electrons, like this, like this, like this. Okay, so with a negative charge here. The force of attraction which holds them together, again, that would be electrostatic force of attraction. Okay, that is why ionic compound should be having high melting point and boiling point. Okay, so now let's move further and discuss about the structure of ionic compound. So ionic compound, structure of ionic compound. So ionic compound would be having a crystal lattice structure. Crystal lattice structure. Why we are calling it as crystal lattice structure? Because it is having three dimensional arrangement of ions. Because it is having three-dimensional arrangement of ions. You can see here it is having three-dimensional arrangement of ions. If you can see here that each sodium is surrounded by two chlorine atoms. Okay, two chlorine, no, sorry, one, two, three, and four. Okay, so we can see that each sodium, this is sodium. If we say this is red, this is sodium, and it is surrounded by this chlorine, chloridine, this chloridine, this chloridine, and this chloridine. Okay, so each sodium, one sodium ion is surrounded by four chloride ion, and each chloride ion, one chloride ion, is surrounded by four sodium ions. So we know that the ratio would become same. Okay, so that is why it is having the formula of NaCl. Okay, so now let's move further towards the physical properties of ionic compound. Physical properties of ionic compound. Ionic compound. Okay. So first property is that they have high melting point and boiling point. The reason is quite same. The reason we have discussed before as well, because of strong electrostatic force of attraction. Because of strong electrostatic force of attraction that we have discussed already. Second is that most of them, word I'm using, most of them are soluble in water. Most of them are soluble in water, but insoluble in organic solvents. But insoluble in organic solvents, soluble in organic solvent. The reason I'm using this word that most of them are soluble in water, the reason behind is that like some are insoluble in water, which we are going to study in the salts chapter, that is AgCl, silver chloride. We have calcium sulfate, okay. We have barium sulfate, okay, and we have lead chloride. So there are some of them are insoluble in water. But actually, why they are soluble in water? The reason is that, for example, if it is having sodium chloride and we are going to dissolve in water, so what happens here? You know, water has this kind of a structure, okay. So what happens? It is having partial negative charge, partial positive charge, partial positive charge. We know in NaCl, it is having Na is having partial positive charge, and chlorine is having negative charge. So oxygen basically attracts the sodium ion here. As it is having negative charge, it is having positive charge. It is also going to attract another sodium ion like this. And this hydrogen is going to attach negative chloride ion here. Negative chloride ion here. And that becomes the reason by which this these ions are going to be separated and they are going to be dissolved in water. Okay. So let's move further towards third reason, third physical property, that ionic compound can conduct electricity, can conduct electricity, Okay, either in either in molten form or in aqueous form or in aqueous form. What we mean by molten form is the form that basically represents the melted form. Okay, that is a melted form. Okay, melted form of anything. Or in aqueous form means like one which is dissolved in water. Dissolved in water. So why? Why they can conduct electricity when in molten form or in aqueous form? Because reason is because of free moving ions, free moving ions or electrons. This is the reason behind why ionic compound can conduct electricity. Okay, either in molten form or in aqueous form. Okay, so reason is that because of free moving ions or electrons. Thank you so much for watching this video. Please do like, subscribe my channel. Thank you so much.